Just like so many of the other Amazon Web Services, every time one comes along that really fits our need, like Cloud Search did so well, it allows us to focus on the product.
At Obama for America, we used pretty much all the services that were available. We used a lot of S3, we used a lot of EC2, we used a lot of RDS, we used a lot of SQS. When we started thinking about how the technology was going to scale, we looked at a lot of the different providers out there, and we noticed that there was one that stood out amongst all the others, and that was AWS.
Businesses like Illumina are getting more and more involved with big data problems, and working with AWS lets us focus on what we're good at, which is doing sequencing, and at the same time have access to amazing computational resources for processing big data problems. AWS was clearly the best as we looked across the combination of security and scalability that we were going to need to build a powerful system to deliver to our customers.
For us to maintain a real-world data platform would just be prohibitively expensive. Instead, what we're able to do is use AWS to basically scale up our experiments and try out our new software on realistic configurations of hundreds or even thousands of computers. AWS gives us the resources to do our work at that scale and to solve real-world problems.
AWS has allowed us to be very efficient in our usage of servers. So instead of buying 1,000 servers to handle the amount of load that we're going to have for the year, we can actually scale up dynamically based on the current load that's going through our system.
When people are connected and are sharing data and insights, especially during times of crisis, it makes everyone's response effective and efficient, and make better use of already limited resources.
It's just really amazing to know that you have some of the world's best engineers and ops people working night and day at AWS on your behalf.
I don't think it would have been possible to reach the same level of performance and scalability without AWS.
Working with AWS has allowed us to run as fast as we can run.
It would have been impossible for us to scale base space the way we have without AWS.
What will you run in the AWS cloud?
Ladies and gentlemen, please welcome Amazon.com's Chief Technology Officer, Dr. Werner Vogels.
Wow. Good morning, Japan. I'm humbled by the interest that you've taken so much time out of your day to actually come and listen to us today. And not only you here in this room, but the thousands of people actually watching this through live streaming as well. Welcome to the two-day AWS Summit here in Tokyo. First, a few housekeeping notes. The wireless is AWS Summit, if you want to make use of that. If you want to give us any feedback on the summit itself, the hashtag is #AWS Summit. And if you have specific criticism of me, you can make use of @Werner to direct your tweets directly to me. Yeah? With that, we're really humbled by the interest that we have worldwide in AWS. Well over 36,000 people have signed up to attend this summit, and I hope that we can give you insight and information that will make it worthwhile for you. Today, the morning, there is a keynote, and this afternoon there will be breakout sessions, and the breakout sessions will be deeply technical, both given by experienced Amazonians, as well by many of our partners and many of our customers. And the keynote this morning as well is not just as much me talking here on stage, because I'm actually just the glue between the most interesting speakers, which are our customers, where you get to hear what our customers have done with our platform, and hopefully that can mean something for you as well, and you can have some lessons from that. So there's sort of three parts to my presentation. A little bit in the beginning about, what is the current state of AWS? Where are we at? And then talk a little bit about the bigger patterns. What are the benefits from cloud computing? Why is it that today, in today's economy, AWS and cloud computing play such a very important role? And how is it transforming IT? And I'll go into different verticals. How is this, what's the role in pharma? What's the role in healthcare? What is the role for media and advertising? And then I'll close off with, looking a bit forward, looking a bit what the kind of things that we're doing here exactly in the Tokyo region. Maybe some news about things that we're launching here in the Tokyo region. And looking a bit forward to, for example, things around big data and things like that. But let's get started. As you may know, AWS is by now 7 years old. And for such an old or young technology, it's amazing the kind of impact that we've had. It's not just that people have built wonderful applications with it, but also the way that their business is being done is transforming. It's not just technology, it is business as well. And that's really important. By now, we have about 33 services. It's not only the basic core building blocks, such as compute and storage and databases, but also services that were real pain points for people. Data warehousing, archiving, search, email. And so we're really focusing on the kind of pain points that you as IT professionals are experiencing and trying to take those away. So that you can actually spend your best efforts on building better products for your customers. And whether your customers are customers on the outside, where you sell your products to, or whether maybe your customers live inside your organization. All of them are customers. And the more time you can spend on actually helping them, instead of having to do things that are just painful, painful IT, then you're just better off as an organization. We're very fortunate to have well over 100,000 companies, customers, using our services worldwide. And there isn't a country where we do not have today AWS customers. And it's not just in countries. Actually, we have some customers that are very, very far away. In this case, it's the NASA Mars rover Curiosity that sends all its data that it retrieves or that it collects on Mars, sends it back into the Amazon cloud, into Amazon S3, the simple storage service, where then scientists can collaborate on that data, and that data is immediately available to researchers worldwide. There are a few things, I think, that set Amazon as a technology provider apart from other providers. One really important thing is that we do not lock you into using any particular technology. The way that our services are built is all over XML and HTTP, so you do not have any particular programming language, any particular library, any particular operating system that you need to use to actually use our services. But the kind of things that you can run inside our EC2 virtual machines, for example, are any operating system, any middleware, any software. So you are in total control of this environment, not us as a provider. So that flexibility is really important to us. And that flexibility is actually not only in the technology, the flexibility is also in the business model. Where in the past, technology providers would lock you in by having very long-term contracts with you. And then, sort of almost extortionist maintenance contracts to go with that. We believe that in today's economy, it is important that you as a customer are in control, instead of we as a provider. So Amazon, the retailer, has as its motto to be the Earth's most customer-centric company. And we try to take those same principles and apply it to us as a service provider as well. Which means that you as a customer are the most important and you should be in control. If we not provide you with the utmost best service at any time, you can walk away. There is no contract that's holding you back with us. In the new world of service providers, it's not the service provider that is in control, it is you, the customer. And that's really what we strive for. We're very fortunate to, here in Japan, have well over 100 local partners to help us out. And there's a great number of names that are international, of course, But for example, Cloudpak and NRI are premium partners, have achieved premium status as partners here by really helping Japanese customers getting onto the AWS cloud platform. It's also something that, another experience that many of our customers have asked us for, to make it very easy to discover software that runs on top of the AWS platform. And we've launched the AWS Marketplace to achieve that, to do that for you, and give you as a customer of this platform a very easy, almost one-click shopping approach to selecting software and deploying. But for our partners, this is a very important platform as well, because by being part of the marketplace, immediately you get in front of hundreds of thousands of customers that may be interested in actually running and deploying your software. So the first thing that really sets Amazon aside is our focus on flexibility and not locking you in. A second thing that sets Amazon aside as a service provider is our relentless focus on driving costs down. For us, this is a high volume, low margin business. That means it is really important to us to help you reduce costs as well. Yeah, so the enormous size of the ecosystem by now, yeah, the fact that we have 9 regions around the world, hundreds of thousands of customers there, who in their term have millions of customers using our services. The continuous launch of new services all helps us grow our economies of scale. And next to that, we are putting an enormous effort in actually innovating in cost efficiency as well. So those two things together, economies of scale and innovation in cost efficiency. If we are then able to actually achieve cost reductions because of that, instead of pocketing that money, we will give that money back to you by actually reducing our prices. We have lowered our pricing 31 times since our launch without any competitive pressure. We do this because we believe that if you help us achieve these economies of scale, we should actually help you reduce your cost. And something that I've noticed quite a few times by being in the office of a CIO or of another type of customer, that they are actually surprised that we are helping them reduce their bill with AWS. We strongly believe that if we help you reduce your IT costs, even if it's with us, that you will be more successful in the long run. And we do this also in an automated way. In our support environment, if you allow us, we will inspect the kind of services that you run at AWS and look at their efficiency. Yeah, our product called Trusted Advisor will inspect the environment that you're running and will give you suggestions, for example, around security or around fault tolerance. But we also can give you suggestions about cost efficiency. We've given well over 300,000 recommendations this year already, and we've actually helped save our customers $22 million with Amazon. We've actually helped our customers lower their bill with AWS. And we strongly believe that this is very important, and we will continue to do so. A third thing that sets Amazon aside is the focus on customer-driven innovation. This means that we will rely on your feedback to help us build the way our services work. Often we will launch a service in a very robust manner because you need to be able to build your business on it, but with a limited feature set. And then we rely on your feedback to actually help us extend the service in the direction where you want it to go. A good example there was, for example, when we launched Dynamodb last year, which is our non-relational, our NoSQL key value store. We launched it only with primary key and range key queries. But we knew already that many customers would want a more expressive way in querying that database. But we waited for feedback from our customers to see whether this was truly important to them. And then earlier this year, we launched what is called local secondary indices, which allows customers to query the database in much more expressive ways. So in some sense, you as our customers are in charge of our roadmap. And we're able to actually adjust our roadmap very rapidly. Now, if you look at the past 5 years, 6 years, as you see, each year we are actually speeding up the delivery of major services and features. Yeah, so last year we launched well over 150 new major features and services. And this year we are already well over 100. Close to 100. Yeah, and we're not even halfway through the year yet. And all these features and services are driven by feedback from you. We rely on your feedback to help us drive this. Yeah, so if you look at some of the things that we've been doing in the past year, we've been really focusing on making it easier for you to run services both on-premise and in the cloud. We give you the virtual private cloud, we give you direct connect, we gave you identity federation, we gave you storage gateway. If you use our simple workflow service, you can execute tasks in the cloud as well as on-premise. And so another thing that we've been really focusing on is listening very careful to our customers, what they consider major pain points. And so enterprises have been giving us the feedback that the explosion of digital data makes it very hard for them to continue to run archiving service and data warehousing services in a cost-effective, scalable manner. So in the last year, we launched Amazon Glacier, which is our archiving service, which will cost you 1 cent a gigabyte a month. And we launched also Amazon Redshift, our data warehousing service, which will cost you $1,000 a terabyte a year. Both of them were received by enterprise customers with great enthusiasm. And if you go around, look for sort of the feedback that has been written publicly about Redshift, is that people are totally amazed about the speed at which it can operate and the scale it can handle. So we're really taking pain points away for our major customers. So we've always used sort of a metric of the number of objects stored in the Amazon Simple Storage Service as sort of an indication of how this business is growing. And it took us about, well, it's almost 6 years to the beginning of last year for us to reach 1 trillion objects in Amazon S3. And 10 months later, we had doubled this. We are now at well over 2 trillion objects in Amazon S3. And as you can see, that is only the beginning of a very steep exponential curve. And we're only at the beginning of that. The real growth is still to come. And really, when we designed Amazon S3, in my wildest dreams, I wouldn't be thinking that we were actually designing a storage service that could handle well over 1.1 million storage transactions a second. This is an amazing service. And it powers many, many pieces of the internet services, as well as many enterprises. And our focus on making it easier for customers is also to help them make it easier to use our services. Many of our customers were using MapReduce or Hadoop to actually do data analytics on our platform. And so we decided to actually build a service called Elastic MapReduce that make it easier for our customers to execute MapReduce programs reliably and scalably on our platform. And so since the launch of this service, which was early in 2010, we've launched well over 5.5 million clusters for our customers. So these are kind of sort of the growth numbers that we normally talk about at Amazon. Now, so I'd like to pull up a quote from Jeff Bezos that he put in a letter to shareholders last year when he talked about the different platforms that we were building at Amazon. And this is a really important quote for us because, if we build these platforms such that you can pursue your dreams. Yeah, and an important word in this quote is actually the word transformative. Yeah? But because what we're seeing is that our services are truly transforming the way that IT business is being done. And I want to go into a bit details about how we see this in sort of different verticals. But first, transformers are, of course, not only in IT, but Transformers are also a well-known game, and as well comics, and there's a number of great movies from Transformers. And the cool thing is this Bumblebee here has actually been rendered for the movie on top of AWS. So if we talk about transformations, first of all, sort of what is actually the driver of the transformation, then a bit into the verticals, and then I'll talk a bit about the future. Yeah, so if you look at what is actually driving the adoption of cloud technologies worldwide, it is not just the fact that we have offered these services, but there are actually larger economic patterns that this falls exactly into place. Yeah, so if you look at sort of the economic drivers, there's an abundance of products in the market, there's murderous competition these days, there's an increasing growing power of consumers to decide what they consume, what, when, and where. And there's actually a reduced loyalty towards brands for which they would normally be for a very long time. Yeah, and of course, since the crisis of 2008, there's limited capital in the market. Now take all these things together, and where in the past, companies, if they would build a product, they could almost be certain that the next generation of that product, they would sell that to exactly the same customer base. That certainty is gone. Whether or not your new products are going to be as successful as your previous products is totally uncertain. And so if there is great uncertainty in a market, you need different resource models. Yeah, and this is just a general economic pattern. You need to acquire resources on demand. You need to release them when you no longer need them. You need to only pay for what you've used. You need to use others' core competencies, and you need to shift capital expense to operational expense. And this is a typical general economic pattern. We've seen this in manufacturing. We've seen this in, for example, HR. Yeah, where you would hire people if you need more of them. You release them when you no longer need them. If you need particular competencies, you will hire those people for a certain period of time for a job to be done. And so these resource patterns have existed for a long time. And actually, it is only now that IT has been able to follow these sort of bigger economic patterns. Yeah? The rise of cloud computing is not just because this is cool new technology, it is because it falls exactly into what the economy needs from service providers right now. And in the past, sort of the traditional service providers have been fighting that tooth and nail, because they don't want these flexible mechanisms, they want long-term contracts. And AWS will give you the ability to execute in a very agile way, in the way that the economy requires today. So, while cloud computing there's very cool technologies in there, the reality is that what really stands cloud computing apart is that the benefits. It is all about the benefits of cloud computing that makes it so powerful. Yeah, so the first benefit is, of course, that you no longer have to apply capital to get these resources. Yeah? You do not have to buy servers up front. It's really shifting from capital to operational. Yeah, and it's not just a matter of actually just shifting capital to OpEx, because that would not have that great benefit. It is actually the ability then to lower your operational expense as well. And here are 3 great examples of Japanese companies that have achieved great cost savings. Yeah, so both Toyota and Kao moved their digital services over to AWS, and both of them saw cost savings between 60 and 80%. Gulliver is another great example where they moved from a PC-based environment to an environment that is purely driven by tablets, where they can actually walk around and address their customers directly because they have the compute at their fingertips. It's not only that they've been able to really innovate their business, they actually were able to achieve 30% cost savings at the same time. A third benefit is something that is really close to my heart. Yeah? Is that you no longer need to guess how much capacity you need to actually support your services or to support the business that you're running. And let me give you an example that's really close to my heart. Yeah? This is sort of a typical weekly traffic pattern at Amazon.com. Yeah? And my rule of thumb that I would use is that I need 15% capacity over expected peak. Which would mean that on a weekly basis, about 40% of my capacity would go unused, just based on this sort of traffic pattern. And that's actually, for many enterprises, a 60% utilization of your resources is actually quite amazing. But for us, Amazon, being a retailer with such low margins, actually losing 40% of your investment that stands there doing nothing is a great waste. And it's actually much worse than this. This is the traffic pattern for November. In the US, at the end of November, the holiday shopping season starts, just after Thanksgiving. There we've got something called Black Friday, and the Monday after that has these days been nicknamed Cyber Monday. And we see traffic spikes that are about 4 times as high as the typical traffic spikes. So again, applying the same rule of 15% over peak, you can see that we need capacity that is much larger than our typically weekly pattern. And for the month of November, because you cannot bring in servers just 2 days before you need them, you need testing and things like that. So for the whole month of November, about 75% of our capacity would stand empty. That's a major waste. And even worse, if I did my capacity planning wrong, if there would be customer traffic spikes that is much higher than anticipated, I would not be able to serve them because I would not have the capacity in-house for that. Now, these are 2 really important dates in this. On November 10, 2010, we turned off the last server, the last web server that was serving Amazon.com. And on October 31st in 2011, we turned off the last web server that was serving our international websites. And today, our traffic pattern now looks like this. Not only traffic pattern, but also the usage pattern. The usage pattern follows exactly the traffic pattern. And it doesn't really matter how big the spikes are going to be, I can actually scale this up and down by a single server at a time. So capacity planning, I can no longer make mistakes because there's always sufficient capacity available in the most cost-effective manner. So the fourth many of our customers will tell you that they came onto the platform because of the cost savings that they could have. But they will all tell you that the real reason why they continue to use AWS and actually expand their use of AWS is the agility that it gives them as a business. Joe Ito actually has the director of the Media Lab of MIT. He has a great quote. He says that if you want to improve innovation, you have to drive the cost of failure to 0. And in the case of AWS, we help our customers to become more experimental. Because the cost of failure is something doesn't succeed, is close to 0. If you had spent $500,000 actually building up an infrastructure to support your experiment, before you're going to pull the plug on that, you have to think very hard. But if you've not spent any capital at all, it's much easier to experiment. Actually, in many organizations, you do not need to go up in the chain of command to actually ask for approval to do your experiment or to do your innovation. You can just go ahead because there's no capital required anymore. It's one of the core pieces, actually, of our whole thinking behind when we started building these services, was that we would help you as customers be able to focus on the things that really matter for your company. Namely, focus on the products that differentiate you. Nick Carr wrote a great article in the Harvard Business Review that said, IT doesn't matter. And Nick didn't mean that IT didn't matter. What he just meant is that everybody has to do IT. It doesn't differentiate you as a company. So if you're able to actually remove your investment in things that don't differentiate you, then you can actually have those resources focus on what really matters for your company, the things that do differentiate you. And so the core principle behind AWS is that we help you focus on things that really matter for your company, not the undifferentiated heavy lifting, such thinking about data centers, thinking about networking, things like that. Or, if you want to launch a service in Europe or in Australia, just being able to get some data center space, you need to involve lawyers, you need to involve, accountants and all these kind of things. And in AWS, the only thing you have to do to launch your business in Australia is to push that one button in the console. And you have your service worldwide. And so it's really important for many of our customers that they're able to not just focus, for example, on the Japanese audience, but Japanese companies that are going global. So, for example, quite a few social gaming companies here in Japan are making use of AWS to target customers worldwide. So, sort of reviewing, these are the benefits of cloud computing. That is what defines cloud computing, its benefits. If it doesn't remove your need for capital, if it doesn't, if it doesn't lower your operational expense, if you still have to take care of all the hardware, it is not a cloud. So all those stories about private cloud, remember, private cloud is just computers in your backyard. Yeah? It doesn't remove the need for capital investment. It doesn't lower your operational expense. You don't become more agile. Yeah? You still have to take care of all the undifferentiated heavy lifting for reliability and scale and going international and multiple data centers and things like that. Cloud gives you the benefits. Yeah? A true cloud will give you these benefits. And actually, there's sort of, in my eyes, a seventh benefit, and that's what I call, is that the cloud is also, because of the nature that we give you all these resources, now programmable resources, it gives you also the foundation for a new style of data architectures, what I call 21st century architectures. And we've seen a number of companies already drive really the way that about thinking about how to build sort of the next generation architectures, the way that you've always wanted to build them. And a good example of that is actually the campaign for Obama for America, the re-election campaign for Barack Obama. And Miles Ward, a solution architect with AWS, made this great website, awsov.info, where in very detailed fashion you can actually see what were all the different resources that this campaign was using in the sort of 21st century architecture thinking. But, instead of me talking about this, I would like to invite Harper Reed, the former CTO of Obama for America campaign, to come on stage and talk to you about it.
Hello, everyone. So I'm Harper Reed, and I was the CTO for Obama for America, the Barack Obama's re-election campaign. But before I talk about the architecture, kind of why we chose AWS, I have to talk about my good friend Michael Slavey. Michael Slavey was a CTO in 2008. And in 2008, they did things like campaigns had always done them. They'd use physical servers, all of the kind of normal IT approach. But things were very different in 2012. They needed something a little bit more, That's my favorite transition, by the way. It's really fun. But that's a really good example of what they needed. They needed new. They needed a fresh approach to technology, especially political technology. And there's a couple things that are really important. Werner talked about these, but the first one is a campaign, especially a presidential campaign, absolutely starts from zero. So in the beginning, we knew we were going to be a billion-dollar enterprise, but we also knew that we had no resources in the beginning, and also we had no actual software or servers or infrastructure. We also knew we had about 18 months. And so that meant that we only could do one thing and one thing only, and that was execute. We had to focus aggressively on execution. So this great architecture map, I'm going to go ahead and scroll it here. As you can see, it's very large. The website is actually very good. We had to use Google Maps because it was so big, so you actually can zoom in on it. It's really exciting. So this is right here, the real infrastructure. And my favorite part is coming, I promise, is right here. Those are exact replicas of the entire thing. And so we were able to do aggressive testing and say, okay, here is our architecture, but I need to make an exact copy of the entire thing by just pressing a button. We did that for staging, for testing, and then also for our failure cluster that we did lots of game day practices and just destroyed. So thank you very much. And without AWS, we could not have been successful.
It is really amazing the kind of things actually that Harper's team has done with this. They were using 2 different regions. Remember that just before the election in the US, we had a major hurricane coming through the East Coast. And of course, these guys needed to be ready on this one day. And this one day only was really going to be their test of being really ready. And for them, they made use of 2 different regions in the US to make sure that under all circumstances, they could survive. This is actually a pattern that I've seen in the past days that I talked to Japanese companies. Quite a few Japanese companies have started to make use of AWS because of our ability to give you that sort of disaster recovery, sort of the next generation disaster recovery. Yeah, so they make use of multiple zones here in the Tokyo region, but they also back up into the Singapore region. And because the Singapore region is identical, you could relaunch your services and relaunch your products there anytime you would want. So if there's ever, again, a horrible natural disaster that might take away, for example, all electricity from the Tokyo region for a long period of time, companies can just restart their complete IT infrastructure from Singapore. And this is a pattern that we see with quite a few Japanese companies that are making use of our services. So, really what we've seen is that there is this sort of old world, where in the old world, products development was going on years. Yeah, and where actually you needed quite a bit of capital up front and you were pretty rigid. You really had to do good planning up front to make sure you had the right resources at the right time and the right scale. In the new world, there's great flexibility. You do not have to decide what kind of servers to buy up front. You can actually experiment. Yeah, and if you make a mistake, that's not a big problem. You just switch to a different instance type. It doesn't cost you any money to make mistakes. Yeah, and so there's infinite scale of them available and at all 0 cost up front. Now, so, given that these are the big drivers behind the sort of transformations that we're seeing, now let's take a look at the number of the industries out there. And, I could talk about possibly every industry vertical. Yeah, whether it is healthcare or transport or hospitality, there isn't a vertical that is not making use of AWS and where their business, their IT business, is being transformed because of it. Yeah, so every industry is being transformed because of the availability of AWS and cloud computing resources. Let's start off with the first one, financial services. Actually, financial services were some of our earliest customers on AWS. When we had launched our services, we started off with the storage service, Amazon S3, but when we launched our compute service, many of the risk managers knew exactly what to do with infinite capacity at their fingertips. Yeah, so if we look at financial services today, there's extreme competition. And there's many new products being developed, and often those products are being presented to their customers through an internet channel first. But there is something very specific, of course, about financial services. They are subject to very strict regulatory compliance and security requirements. And we see that almost all of our customers in the financial services space are capable of meeting those requirements. Yeah, the requirements around regulatory, compliance, and security. They're all able to meet those requirements very simply on top of the AWS platform. An example here in Japan is, for example, Tokyo Marine, which is a large insurer that has certified AWS for production by their IT systems. But also in the US, large insurers such as Farmers, or very new insurance types, such as offered by the Climate Corporation, who offer a complete data-driven insurance for farmers to actually supplement their income when the crop yield is not high enough based on weather conditions. And the thing that makes the Climate Corporation different as an insurer is that they no longer send agents to actually validate claims. Because they are complete data-driven insurance, they know already what has happened in the particular area where a farmer is active. And they start sending checks without the farmer even having to ask for it. This is a very different type of insurer that is possible because of the enormous computational power of the AWS platform. And one of our earliest customers also was the NASDAQ. Of course, you probably know the NASDAQ as one of the trading platforms out in the US. But they also have a data group that actually serves data and historical information back to its customers. And one of the earliest applications running on AWS was actually the market replay application, where they stored all historical data in Amazon S3, and then customers could download an application that would connect to Amazon S3, and you could do historical market research. They didn't know on forehand whether this was a product that was going to be successful or not. It's really an experiment for them. But because it was very successful, they didn't have to make any investment in their own IT infrastructure. And now that they see that actually they've collected a lot of this data in Amazon S3, they have put an API on top of it and are now serving historical market data to everyone out there who wants to use it. The NASDAQ then also went into a second business, something which we call FinCloud, financial cloud. The NASDAQ FinCloud helps other banks and financial institutions with their long-term storage of documents that are subject to regulatory requirements. And so they take on this burden for all these financial institutions, and they store all these documents securely into the AWS cloud. But we also see regular banks just making use of our platform. Yeah? Commonwealth Bank of Australia has most of their digital properties running on AWS. Bank Inter does a large-scale risk modeling and analysis. And actually, they've been able to reduce the time frame from many days to hours in terms of where they actually can do the effective modeling. And recently, the Dutch Central Bank has approved that banks can make use of the AWS platform for their banking. And so Robeco, a retail bank, an investment bank in the Netherlands, is now moving all their retail banking over to AWS. And they make use of Open as a platform for banking in the cloud. Another vertical industry that is making use of a lot of cloud resources is that of media and advertising. So this is a graph of advertising revenues in the US. And this is a graph given to us by the Newspaper Association of America. As you can see, the revenues, the ad revenues, both in print as well as online, are at historical lows, which means that the media and advertisement business is really frantically experimenting in trying to find new ways to monetize their content. And as such, we have many of the world's largest newspapers and magazines making use of AWS and trying to experiment and find new ways in reaching their customers. That, you see some of the world's largest names, both also here in Japan. But a good example of an old-style media world that is completely upset by a newcomer, Netflix really fits into the pattern that giving complete control to customers, such that they can watch what they want to watch at a time that is convenient for them. And the stories are that Netflix, at prime time in the evening in the US, consumes about 30% of the total internet traffic. But it's not just watching, so to say, on demand. Also, live TV is being streamed from the cloud. ABC Disney is a large broadcaster in the US, and they are broadcasting to all mobile devices by uploading in real time their content into the AWS cloud, where it is then transcoded for each individual device, and where each individual device also gets media insertion based on the locality where they are. This completely revolutionizes the way that ad targeting is done, as well as a way that they can reach mobile devices anywhere in the world. And mobile devices have a big impact on the way that media is being consumed. And one thing that we see, and this is an example of the Amazon Kindle, is that content no longer goes onto the device. It is actually content is being stored in the cloud, and these devices are just a window into what's happening in the cloud. And what you will see is that very soon, you'll be able to access your data, whether it's your music, whether it is your books, whether it is your subscriptions, from any device anywhere in the world. And it may not be the traditional device that you think about. It might be that if you walk into your treadmill in your gym tomorrow and you step on the treadmill, that treadmill reconfigures itself to present your content, your movies, your music to you. And Amazon also has already made contracts, for example, with Ford Motors, where all the music that you've bought on Amazon, you can actually play that from your radio in the new Ford cars. Yeah, so all of this content will live in the cloud, and these devices, all these devices are just a window onto that data. And advertising, of course, remains important. Here you see three large ad agencies and ad traders here in Japan that all need to move faster. And they all make use of the AWS platform to offer their services to you. But I would like to invite Koyangi-san onto stage to actually talk about how the Nikkei is making use of AWS.
So all of a sudden, I'm speaking in Japanese. You might feel that it's disruptive, but anyway, my name is Chaya Nagi. I am a journalist for a newspaper company. About 4 years, I have been involved in the development. Basically, service design is what I've been doing for that piece. Today is 5th of June, and it so happens to be that at the end of last month, we launched a new service. Just this. So the online service started in March of 2010 Now, finally, it has been optimized to tablets and smartphones. That was released end of May. HTML5 is what we use, web application. So you probably use smartphones or tablets and go to Nikkei.com. If that's the URL you access, then automatically that terminal will be detected and the content will be optimized. That's the service that we launched. Now, we use Amazon AWS, so let me share with you what benefits we have enjoyed. And I'm sure I don't need to talk about this, but obviously the first and foremost was the relief that we got from internal support that we needed to provide, and then we're a newspaper website. So if there's something that happens, obviously if there's an event, then there's a peak in access. And so if we try to do this on-premise with owned systems, we learned about the Amazon.com situation earlier, but, we would have to have a lot of capacity to accommodate this. So we wanted to, in fact, be relieved of not having to worry about all of that. Now, like I mentioned earlier, it's been 3 years since our service became digital, but after 3 years, finally, we have started to do this on AWS. Now, even in the past, we wanted to do this on public cloud. We wanted to do this for quite a long time. These are the kind of services that we developed. There were native applications, we had PC sites. At the very beginning, we had things for feature phones as well. And all of that in the past were supported on-premise and developed on-premise, which meant that the lead time was extremely long and we could not reduce the time to market. Well, obviously we have money, but we didn't have time, we didn't have the human resources. So therefore, we wanted to take care of that issue, especially around server management, updating the servers and updating the applications, because that was human resource intensive. And we wanted to, in fact, shift that more to the development of applications. And it took us 3 years to do that. Now, why so?
That was because back in 2010, when I had actually written the article, well, that's 3 years ago, there's some major Japanese company, had said what they think about the cloud. And on the top of the reasons, the concern for the security. That's the same for us too. The service has already launched by that time. However, even today, our management, are saying that, is it okay to have our data on the cloud? Maybe our big news on the cloud, somebody would peek into it. They're all worried about it. But at this point, many of the large enterprises who had already adopted the cloud services, their satisfaction level is very high. And one of the reasons is because of the security. Their biggest concern was security. However, the reason for the satisfaction is also security. What does that mean? Well, I say that to our management, myself, within my own organization. Everyone has money. Where do you keep your money? In the safe at home or at the bank? Which is more convenient? Which is safer? It's the same thing. The data could be stored in the bank. And I had kept saying that for the 3 years. And finally, we are here. And thanks to AWS, the response for the development for the services will be able to focus more on that. Thank you, Amazon. That's all from me.
We're really honored that such an important Japanese company like the Nikkei has considered to use AWS for to support its business. Another area that is often subject to all sorts of regulatory requirements is that of healthcare and biotech. But these are also businesses that are changing dramatically. Because in the past, biotech, pharma was able to actually take their time in developing their products. But because of the intensifying competition, that's often no longer possible. So many of these companies rely on high-performance computing to actually support their products. For example, Unilever makes use of the Genomics platform for doing much of research into building better products, for example, building better toothpastes or building better deodorants, much of which is driven by genomics research. And this is significantly sped up by the use of their Eagle Genomics platform, which runs on top of AWS. But much of sequencing you see maybe in the intro movie that you saw was actually also Illumina, which is a device that actually does the sequencing for you and then actually spits out these sequences directly into Amazon S3, where it's then available for researchers to use. But also here in Japan, we have great customers in, for example, Toshiba Medical Imaging. In many of the medical imaging world, the way that data, that these high-resolution medical images have been archived is by transforming them onto film and then storing them for many years to come. It's obvious that much of the resolution, much of the important data is lost in that transfer process. Toshiba Medical Images now makes use of storing the original data from much of their CAT scans, their MRI scans, directly into Amazon S3 for long-term archiving. And of course, because they're subject to privacy regulations around personal identifiable information, as well as with respect to medical information, they are encrypting all the data that lives in S3, and as such are able to meet the regulatory requirements. Another important area, healthcare, is becoming more and more collaborative. And one of the projects that AWS is involved with is called the Genome Project, where we're making, together with the National Institute of Health in the US, where we are making the genomes of well over 1,700 individuals available for everybody else to use. This is a public data set that lives in AWS S3. And this data set is well over 200 terabytes. And actually analyzing that data set is well beyond the capabilities of many individual researchers. But in the cloud, they can have access to unlimited resources to do all the research that they want. Another collaborative example is that of the Center for Disease Control in the US. This is an organization that collects information about health and diseases throughout the US and also throughout the world. They used to do this by telephone and fax. And actually sharing their information was really difficult. And so they built a system called BioSense that collects all the data from throughout the US in real time and then collaboratively actually analyzes that data and brings it then to all the different stakeholders, which can be the general public, as well as government individuals, healthcare workers, and of course people at the CDC themselves. And this platform now is able to provide this data in real time to their customers. And you can get graphs like this, which is, for example, the spread of influenza through the US during the past influenza epidemic. Another vertical that has been touched in many ways by AWS is that of manufacturing. So manufacturing is also undergoing major changes. Yeah, where in the past you would do that in your own factory. Today's much manufacturing, certainly for larger corporations, is a collaborative affair. It's where many companies are actually working together to actually build that one product. A good example is that, for example, the Boeing 787, where large parts of that airplane were actually built here in Japan and then shipped over to the US to be put together there into one single airplane. A company that supports that is, for example, Autodesk. They make use of AWS to provide a collaborative environment for manufacturers to, in collaboration, build and define and model new products that they're working on. And also, there's quite a few Japanese companies in the manufacturing space, both UMC as well as Anritsu, both building devices, but all making use of AWS to actually become more agile. Both of them have moved their SAP environments over to AWS, their classic ERP systems. UMC is actually a very interesting story because they're also an example of a company that had a desire to go global. And UMC wanted to expand into different areas in Asia, but could not serve those areas from the Tokyo region. So they launched a complete new environment based on SAP in Singapore to target that particular area of Asia with a much lower latency. Actually, I would like to introduce Fujiwari-san from Toyota Media Services Corporation to actually tell us about how they are using AWS services.
Thank you for introduction. My name is Fujiwara of Toyota Media Service. At Toyota, I'd like to introduce our company, Toyota Media Service. B2C area system for Toyota Automobile, we are in charge of, for instance, for consumers, the web services or telematics services. That's what we are responsible for. And here, I would like to introduce the concept of just-in-time at Toyota and compare that against cloud because they have a lot of similarities. Just-in-time, first of all, what is it? That's the Toyota method, and there are two pillars. Make and transport what's needed when needed. And what that means is that everything not needed is a waste, so let's stop it. And therefore, the concept of just-in-time is introduced. And another important aspect is the automation. Automatically detect and stop everything that is of poor quality. In other words, never a defect. These two we practice. Next. How did this Toyota method born? Or how did it come about? So we would like to go back in the history. Toyota, when as a venture business, started to make the automobile. We have a history of business crisis, and at that time, we had made a lot of trucks. Of course, the plan was that we sell a lot of them, but we had fallen into the severe cash flow problem. We're out of money, and the banks would not loan us the money. And at this time, the Toyota Automobile Company, the venture part is the manufacturing part. And the bankers said that they would loan money for the sales company, but not the manufacturers. So, for us to get the money from the bank, we had separated our company and divested in the sales company. It was established, and we were supposed to go through the restructuring, and we had gone into the labor dispute, and our president had designated. And there, the Toyota method was born. And the idea was that we are going to have this just-in-time and automation, the Toyota methodology, in order to implement the absolute cost reduction. Now, the commonalities between Amazon and Toyota, I would like to introduce. First of all, we are customer-focused, and Amazon would deliver the necessary things at a reasonable cost fast. E-commerce site they originally had, and offer the system as a service. That's very similar to Toyota, because Toyota would make a good car and deliver those to the customers fast and cheap, or at a reasonable price. And of course, the quality is given. The idea for us to keep the quality is the satisfaction of the customer.
But that changes. If we give them something good, they want something better, and they want it faster. So in order to keep satisfying the customer, you need to consider what the expectation is of the customer and try to respond to that and continue to do that. Now, the current information system, what does it look like? We have a complicated situation. This is the financing system. There's company A, the developer, and we have dedicated infrastructure, and the database application is there. This is the telematics service, and this is the consumer service. And right over here is where we get support from Amazon. So this is the structure, so you can see that it's complicated, redundant functions. We have many user databases, similar functionalities overlapping. So to create new services and develop new services, obviously it takes time, and we can't reduce cost any further. We call this the Castle of Howell. In other words, it's all messy. You never know where you can find something. And therefore, I'd like to use an analogy of sushi, a sushi restaurant, to describe this. You capacity plan, trying to understand how much you will sell in nigiri versus bowls versus rolls. So, considering all of that, it was decided that they invested into infrastructure like ports and vessels. So they had to design that. They would fish. The yield, the tuna that's taken from the ocean, is then sent to dedicated plants to cut them up for particular dishes. So you cut them up in different ways. But if you sell, let's say, a particular dish, a rice bowl with tuna on the top, then because it was so popular, you run out of cut tuna for that dish. But on the other hand, you have an abundance of tuna cut for other dishes. But in order to start small, this is not a very good approach. So rather than investing in the infrastructure like ports and vessels, because you don't know when you're going to recover the cost, you should take a different approach. So here comes the paradigm shift for the IT system development. So, our approach to development is from making to using and to combining. So we want to apply the just-in-time approach as well, faster and cheaper, reducing the maintenance cost to half of what it is, and speeding up in responding to changes. And so we focused on the features provided by the IT system and consider them as services. And using SOA and cloud services, we can respond more quickly.
いうやり方です。で、そうするとこのようになりますね。
So at the end of the day, this is what it turned into. So you have a general platform. This is for cost reduction. It can be general. It doesn't have to be competitive. But there are areas that you have to be unique and original. So that is where we need to make the applications ourselves. Or we can go to outsourced services. And we can go via the enterprise service bus, via the internet, enabling the business process to the end users. So that means the sushi restaurant that I was talking about earlier. You know, you have blocks of tuna on the counter at a sushi restaurant, and in order to do that, you go to the market and find good fish. You cut them into blocks rather than to smaller cuts because you will be limited to what dish it can be used for. And then you wait for the customer's order. It's a hot day, the customer may order beer, you have good communication over the counter, and finally the customer orders a nigiri, or maybe just sashimi, or maybe you want to mince the tuna up to make tataki, and the block will allow you to do it faster. And you make your sales, and then using that, you can go and buy fish the next day. And that will give you better rotation. That's the just-in-time approach here. And if you purchase avocado and crab and mayonnaise and place it on your counter, then you'll be able to make a California roll. And as long as you have the ingredients, you can start providing the California roll even on the next day. That's the idea of being quick in lead time. So I gave this analogy to my internal people because they said that they didn't understand the concept that I was trying to convey. They wanted me to take them to a sushi restaurant that did exactly this, but anyway, at the end of the day, we were able to achieve this in our company. So as a result of implementing cloud, we were able to migrate off from on-premise to cloud. That was completed in March of 2013. And over the period of 5 years, including the running cost, in other words, the migration cost, we were able to reduce cost by 50%. Now, out of this experience, we found that every 3 months, the AWS cost goes down. So therefore, we'll probably see a bigger impact than this. So why not everyone do this? And then right after the migration, obviously response went down. In other words, the application setup and modifications were done, but we didn't get the response that we thought we could get. And so we wanted to add servers. So a single command line allowed us to go double or even triple the amount of server resources we had. And that was done first to respond to the situation, and then we identified the issues, siloed them or isolated them to handle them application by application, and then went back to the normal level of server resources. And if this was all on-premise, you would not be able to do that. So we are a systems company of Toyota, but this is the approach that we take. There are things that can be done, and there are things that cannot be done. In other words, we can reduce cost, but we cannot increase cost. We cannot extend the lead time, but we can reduce the lead time. So it's either or. So if you don't know which way it's going to be, then just try it out. That is the Toyota mindset. Because at least if you gain the experience, then you have a lesson learned. If you can identify what's not good about what you did, then you'll be able to improve. For example, if you use AWS and if you don't like something about it, tell Werner and he'll be able to fix it for you. The worst thing you can do is think about these ideas and not execute. That is the real message of the Toyota approach. So this is the Toyota approach, and it was first an idea put together by Taiichi Ono, a vice president in the past. And so this is the message, which means continued improvement and the spirit of continued improvement. And that is really the key of the Toyota spirit. And improvement is something that should be done day to day. And improvement is not about thinking about a large-scale revolution, but it's more a day-to-day continuous effort that leads to improvement. Thank you very much.
Thank you for that excellent presentation. It's very interesting to see, how Toyota and Amazon have sort of similar principles when it comes to, really focusing on the customer. Now, many of the things that we do around AWS have all to do with reducing waste. Yeah? Making sure that you no longer have to waste time on things that are not relevant for your business. Now let's take a look at what's in store for the coming time. Let me make a few observations and also actually talk about some very interesting developments here in Japan. So, for some time already, Amazon Web Services have been an excellent platform for doing high-performance compute on. And high-performance compute these days is used by almost all in different industries. And whether that is, whether it's healthcare, whether it is biotech, whether it's oil and gas, energy, but also younger businesses focusing on how to better target my customers are all making use of high-performance compute. And with that, I'm very, very happy to announce that we now are making our cluster compute, our high-performance compute instances available here in the Tokyo regions for all of you to use. And this is the two HPC instances, the CC2 cluster compute instance types, but also the high memory, the high I/O, and the high storage instance types are available for you to use now here in the Tokyo region. Such that you can do high-performance compute on these excellent top-of-the-line instance models. But that's not the only form of HPC, high-performance compute, that is taking part of our platform. We have a customer, or a partner actually, that has completely revolutionized the way that HPC has been done in the cloud. They have turned HPC into a utility. And I'd like to invite Jason Stowe on stage, the CEO of Cycle Compute, who will tell you about the great impact that his company has on many different industries that are interested in HPC. Jason.
Werner-san, arigato, konnichiwa, watashi no namae.
My name is Jason Stowe.
Cycle Computing, and today I'm here to tell you a little bit about how the AWS platform and our software enable customers to do impossible science. We are now able to do forms of engineering, forms of research, forms of life sciences that were impossible to do before the existence of Amazon and the existence of the cloud. Cycle Computing writes software with the specific goal of making HPC universally accessible and a utility. So our fundamental belief, what we believe most, is that this utility high-performance computing access will accelerate invention. It will enable people to write and ask questions, get answers to them that were impossible to reach before. Now, in our industry, before, people used to have to run their computation on a fixed size internal cluster. The problem is that these fixed size clusters are in a way like a jail. They constrain the questions that you can ask to what fits inside them. So over time, they're too small when you need them most, i.e. when they're full, you wish they were considerably larger so you could run your work that much faster. And when you're not using them, when they're not fully utilized, you're paid for compute time that is being wasted, as has been so eloquently said in the last presentation. And this problem, this challenge, the constraining of questions to those that fit in the infrastructure that you happen to be able to afford last year, for example, is a pervasive problem across many industries. In Amazon reInvent last November, we were fortunate enough to have many customers talk about their use of HPC and Amazon to accelerate their science, to accelerate their engineering, to accelerate their manufacturing. Johnson & Johnson talked about medical device manufacturer and workloads that they had in-house. Pacific Life Insurance, Life Technologies, Hartford Life Insurance, and Novartis. All of these companies across life sciences, medical device manufacturing, and insurance and financial services are using Amazon's platform to make themselves able to answer bigger questions than what fits on their internal environments. So our tenet is that today we can take and put supercomputing class power in the hands of individual researchers. We can put supercomputers at your fingertips. Now, last year at the New York AWS Summit, we were proud enough to be able to announce a 6,700 server HPC environment that we constructed and used over a 3-hour period. This was covered fairly broadly in the media at the Wall Street Journal, the New York Times, Wired, among many others. Now, this computer ran across every public region inside of AWS. It ran in Singapore, Japan, Brazil, Oregon, Northern California, Virginia, and the EU. We accumulated 50,000 cores to run 12 years of science in about 3 hours. And today, I'm here to tell you about a 10,000 server cluster that we created on AWS to answer a single large pharma, a Big 10 pharma's individual scientific question against a cancer target. But that's not the only example I'm going to talk about today. We have 2 others. We have one spanning manufacturing, dealing with nuclear reactor simulation for safety certification, as well as an additional in genomics research. So let's consider drug design first. There are, according to GlobalCan, as part of a World Health Organization study in 2008, approximately 12.5 million new cases of cancer every year. In addition, there are 2 million new type 2 diabetics. There's 200,000 type 1s. I'm one of them. And I can tell you from firsthand experience that the instant they cure type 1 diabetes, I'm getting it. Not a day will pass. They will announce they have it, I will get it. And that is because in this area, each day is precious and costly. And if you can remove days or weeks or months from drug development pipelines, that saves lives, especially when it's affiliated with cancer. So let's talk about an example from this field. We had a top 10 pharma needed to run approximately 340,000 hours of molecular modeling. Now, this is a highly compute-intensive process where you have a protein affiliated with cancer that you may be trying to inhibit, for example, and you have millions and millions of compounds that you need to test to see whether they fit, much like a lock and key. The problem is this compute capacity is so large, it's unfeasible to do it in-house. So what we did was we created a 10,600 instance environment on top of Amazon. Now this is a tool called Chef. It's an open source software configuration management system. This command line is showing us at the time that we had 10,599 servers. The AWS console showed us that we had, again, about 10,600 servers available. Our browser was unable to render the table control for the AWS console, so this is actually the only part of that web page that rendered. The remainder had so much data about all the instances we had that our browser couldn't keep up and actually render the entire page. And this is our view, essentially, of 10,000 green and red dots. Each one of these is a live server that's being actively tracked. The red ones are essentially in some form of error condition, and we're in situ changing them. We are either correcting them or tossing them back so we can get properly functioning resources. And in addition to celebrating a little bit, once this run was done, we bought our employees Retina displays for future HPC runs. This one particular cluster ran approximately 341,000 hours. That's 14,000 days of cancer science, 39 years of computing. We created approximately 10,600 instances into one cluster over a 2-hour period. And this ran approximately 39 years of science in somewhere in the neighborhood of 11 hours. At a cost of $4,372. So again, this is all of the power of AWS being driven on one problem for one researcher at a Big 10 pharma to do 4 decades of computing in 11 hours. And you remember what I said about taking time off saves lives. And we did this for approximately 450,000 yen. That's all it cost. Now the question is, does this lead to actual treatments? Well, thankfully, at the AWS reInvent Summit in November, Novartis talked a little bit about a run that we had done with them 2 years ago. Now, the problem with these use cases and these case studies is they're very strategic, so it's hard to get people to talk about them. But at AWS reInvent, Novartis mentioned that a run that we did with them using 30,000 cores across 3 different regions actually yielded 3 new compounds against a cancer target that are in the wet lab and heading to clinical trials. This is a huge benefit for any drug company, being able to discover compounds that would never have been found otherwise. And because 2 years have passed, they've been able to trace this back to this one individual run on AWS. So next up, let me talk very quickly about Cad Cam and Manufacturing. So this was a Global 2000 company who was doing a simulation of a nuclear reactor design. Essentially, this was for a safety certification. So the idea is they would actually simulate soil sampling and testing and what have you so that they could be able to meet regulatory requirements. We used the CC2 instances that Werner mentioned earlier. These new speedy instances ran the workload 40% faster than their internal systems. And in addition to this, because this is the cloud and we have utility access, rather than having one cluster, we spun up many of them, so they could run the workload 5 to 10 times faster as well. This is the equivalent of taking a year's worth of certification results, something that would have been 6 to 9 months late, and running it on time and in about 2 to 3 months. So we were able to get safer designs faster and fundamentally more efficiently. Lastly, I'd like to talk to you a little bit about genomics. Now, this is a biotech use case. This is essentially a form of research. The group out of the Morgridge Institute for Research, they made Time magazine cover in the 90s for the ability to take your skin cells and turn them into stem cells that can then turn into other types of cells within your body, like neurons or heart cells, et cetera. Essentially, they wanted to be able to create a lookup table so that researchers could replicate disease inside the Petri dish. And they would know that they had done this correctly, that these stem cells were, in fact, actually turning into cardiac cells, for example. So they ran this research, which took approximately 78 terabytes of data. This was a sample-to-sample comparison. And this is from the researcher Victor Ruadi's presentation on the subject. And this lookup table calculation took over 1 million hours of computing on AWS. It's 115 years, over a compute century. And we finished that in a week. 1 week. So if you had taken one modern Sandy Bridge processor and run it from 1897, the year the computer was first used, meaning an electronic calculator, and ran it all the way through the 20th century, it would have finished mid last year in 2012. And we did this for about $19,555. So it is now faster and easier to use stem cells to fight disease. So across all of these use cases, from life sciences, pharmaceuticals, to manufacturing, to biotech, we have seen use cases that fundamentally accelerate science. They make it faster to do engineering, enable you to approach problems that are far larger and can fundamentally change your research, fundamentally change your business, and do it efficiently in a way that removes waste and impacts lives. And our belief is that this utility HPC capability, what we get from the awesome power of Amazon's compute infrastructure, will accelerate invention. It will allow us to ask the big questions and get the big answers and push humanity forward. And fundamentally, we think Amazon's compute power makes impossible big science possible. Arigato.
Thanks, Jason. This is an amazing story. And I think we really have to thank our partner, Cycle Compute and Jason, for really changing the way research is being done. And believe me, we are extremely humbled as AWS to be involved with radical changes in the way that, for example, cancer drugs are being created and much faster being brought to market. And with that, saving lives. There's also another side to data analytics that we haven't talked about much yet, and that is what we call with a friendly name, big data. And a good example of that, in the first day of a baby's life today, 70 times the content of the Library of Congress is being created digitally about that baby. And that's just the beginning. The enormous explosion of digital data helps also businesses create much better processes in targeting their customers. So what often businesses are making use of big data and data analytics is to create a competitive advantage, to better understand their customers. Because business is starting to understand that really understanding the customer is what will allow them to be competitive. So who is your customer? How is he using our product? What does he really like? How does he interact about the product with other people? And so if we look at big data, there's a number of things that we see. A clear move to real time, where actually these data streams are being analyzed in real time on the cloud and then drive processes to better target customers. A deeper integration with cloud is on the way. And what we also see is that more vertical applications are being developed. Where in the past maybe a customer would still be running its own Hadoop processes or some other analytics, there's a whole range of new vertical products coming into the market. Where, for example, it makes it easy for you to do customer segmentation to do better advertisement targeting towards your customers. And what we see is this execution layer that we have on Amazon. It's called Elastic MapReduce. Although it is a very effective engine to do distributed execution of these sort of analytics programs, it is not an analytics layer by itself. And what we see is that this layer will become the foundation for multiple layers on top of this that will really target analytics. And many of our partners are building these layers for us. And there's also a different style of analytics that still is close to sort of the traditional data warehousing, especially if you want to ask questions about the data using SQL. And as I mentioned earlier in my presentation, we've developed Amazon Redshift specifically for this goal, where the enormous explosion in digital data allows you to build a data warehouse that is absolutely blindingly fast. If you look at the feedback that we've been getting from our customers, and customers are quite vocal about it around the internet, they are all amazed about the speed with which you can load data into Redshift and then the performance of Redshift itself. And all of that for under $1,000 per terabyte per year. But it also makes it possible to actually run a data warehouse just a number of hours a week. You no longer have to have investments in enormous capacity, in big iron on-premise, to actually run a data warehouse just only when you need it. And I'm really proud to announce that today, Amazon Redshift will be available in the Tokyo region for you to use. The only thing you have to do, the only thing you have to do is log into the AWS console, go to the Redshift tab, point to your data source, and you can immediately start using Amazon Redshift for your data, to address your data warehouse problems at enormous speed, at a fraction of the cost of the traditional data warehousing. And there's also something else I would like to draw your attention to that is available today. As you know, Amazon has started an AWS training program, and this training program is now available for you, both at the level of basic knowledge of AWS as well as architectural level, is available for you in Japanese. And on top of that, we've created a certification program for you, that if you pass an exam, you will be a certified AWS developer or AWS architect. And today, you can actually take the exams for the certification program downstairs at the first floor for you immediately. So, you know, after these 2 days, or even today, you can go home as a certified AWS developer or architect. With that, I hope that we've given you a bit of insight into our business, into how our technologies are actually changing many other businesses around the world, how our customers are making use of AWS. But most importantly, I hope that you've received a sort of a glance in how you can pursue your dreams, and how you can pursue your dreams all powered by AWS. With that, thank you for your attention today, and I hope you have a very successful summit for the rest of the days. Thank you very much.
以上で Day1 オープニングキーノを終了いたします。